All right, let's get right into it. For the last couple of years, all we've heard about is prompt engineering. But as AI models get way more powerful, a new, much bigger idea is taking over. So, welcome to what's next, context engineering.
So yeah, we're all pretty familiar with prompt engineering by now, right? It's the art of crafting just the right words to get the best possible answer from an AI. We've all been there, tweaking a sentence, rephrasing a question, just hoping to hit on that magic formula. But what happens when the job is just too big for one single prompt? When you need an AI to work on a project for hours or even days, remembering what it did and learning as it goes? Well, that's where the old way of doing things really starts to break down, and we need something more. And here's the crucial difference. Prompt engineering is all about that one perfect instruction. But context engineering, that's about managing the entire universe of information the AI is looking at in any given moment. We're talking instructions, tools, conversation history, the whole shebang. It's not just a one-and-done task. It's this constant, ongoing process of deciding what the AI should pay attention to.
Which, is a totally fair question, right? Why not just build a massive context window and cram in all the information it could ever need? Problem solved. Well, as it turns out, it's not nearly that simple.
The heart of the issue is this. Just like us, AI models have a limited attention budget. You can't just keep pouring information into their heads and expect them to remember everything perfectly. Their ability to focus gets stretched thinner and thinner, and that leads to a very specific and very big problem. And that problem has a name: context rot. I love that term. It basically means that the more stuff you cram into the AI's working memory, the worse it performs. It starts losing track of details, getting confused, and its ability to find that one crucial piece of information, that needle in the haystack, just completely tanks. Now, this isn't some bug we can just patch. It's actually a core feature of how these models are built. It's baked into their underlying transformer architecture, which is designed so that every single piece of information, every token, which is basically a word or a part of a word, has to connect with every other token. And that design choice, it creates a massive, massive computational headache. Let's try to put some numbers on that to make it real. If you have just 100 tokens, that's about 75 words, the model already has to juggle 10,000 potential relationships between them. And that's just a tiny amount of text. But watch what happens when we go up to just 1,000 tokens. The number of relationships doesn't just grow by a factor of 10, it explodes to 1 million. This is what's known as the n-squared problem. The complexity just skyrockets. And that is exactly why the AI's attention budget gets totally blown out. It's just overwhelmed. Okay, so this brings us right back to the main challenge. If we can't give the AI an infinite memory, how do we work with its limits? How do we carefully manage that precious attention budget to get the absolute best performance? Well, let's take a look at what an effective context is actually made of. It all comes down to being incredibly deliberate about what you include. Every single piece matters, from your crystal clear system prompts to the tools you give it, to providing just a few perfect canonical examples instead of 100 messy ones, and of course, carefully curating the message history.
And for those system prompts, you're really looking for a Goldilocks zone. On one hand, you can't be too brittle, with rigid, hard-coded rules that just shatter the second something unexpected pops up. But on the other hand, you can't be too vague, giving it fuzzy advice that it can't actually follow. You need something that's just right, specific enough to guide it, but flexible enough to handle the real world.
Okay, so that covers how to manage what goes inside one context window. But what about the really huge jobs? I'm talking about migrating an entire code base or doing a massive research project, things that take hours and generate way more text than any context window could possibly hold. For that, we need to level up our strategies. To tackle these long horizon tasks, 3 really powerful strategies are emerging. We're going to break down each one: compaction, structured note-taking, and what are called sub-agent architectures. First up is compaction. Now, this one is so beautifully simple and effective. The idea is, right before the AI's memory gets full, you just ask it to stop and summarize the most important things that have happened so far. Key decisions, open questions, critical facts. Then you start a brand new session with that tight little summary right at the top. It gets a clean slate, but it still remembers everything that matters. The second strategy is called structured note-taking. Think of this as giving the AI its own notebook.
Instead of just summarizing, the agent is actively writing and updating its own notes in an external file, like a little markdown file. It's like the AI is creating its own personal scratch pad or a to-do list to keep itself on track over a really long time. And this example just perfectly shows how powerful that is. Researchers had an AI agent play the game Pokemon, and it started keeping its own notes. It would write things exactly like this, tracking its progress with incredible detail over thousands of steps. When its context window reset, it would just read its own notes and pick up right where it left off. That's how you get long-term memory. It's brilliant. And finally, we have sub-agent architectures. This is basically the divide and conquer strategy. Instead of having one giant AI trying to do everything at once, you have a main manager agent that delegates specific tasks to smaller, specialized sub-agents. Each of those sub-agents can use its entire context window to focus deeply on one single problem, and then it just reports back a condensed summary to the manager. It's a super clean way to organize complex work.
So whether you're using compaction, note-taking, or sub-agents, you start to see the theme here, right? The core philosophy is always the same, and this is really the main takeaway. It's not about just shoving more data at the model. It's about giving it the right data. The whole game is to find that smallest, most perfect set of high-signal tokens, the most valuable bits of information that are going to get you the result you want. It's all about quality over quantity.
And that brings this whole idea full circle, doesn't it? This is maybe the most human part of this entire AI challenge. For these incredibly complex models, just like for every one of us, success isn't really about how much you know or how much information you have access to. It's about what you choose to pay attention to. It's all about focus. Which leaves us with one last big question to think about. As these AI agents get more and more autonomous, the biggest challenge isn't going to be teaching them what to know. The real art and science of context engineering is going to be teaching them the much harder skill of what to filter out, what to forget, and ultimately what to ignore.